Well, this 13th example is quite a bit more difficult. You need to remember all the properties that we've done so far with logarithms to get this problem figured out. So the first thing you want to do on this one actually is use the power rule. We're going to bring this 2 right in there, and then we can use the quotient rule with that minus. That minus is indicating a quotient rule, quotient property. So I'm going to rewrite this: log base 3 x plus 4 squared minus log base 3 9 equals 2. And then we're going to use that quotient rule that we had in a previous section. So that gives us log base 3 of x plus 4 squared divided by 9 equals 2. So we put that together. This whole thing right here is the quotient property from the previous section. Now, I know it's a mess, but now we can rewrite it. We can get rid of this logarithm. 3 to that power equals that stuff, all of that stuff, okay? So 3 squared equals x plus 4 squared over 9. That's our next step. So the first up here, we use the power rule, then we use the quotient rule. Now we're rewriting it. So basically, we're trying to get rid of the logarithms. It's a much better looking equation now. So we're just a couple, maybe 3 steps away from being done with this one. We're going to multiply both sides by 9. Those 9s cancel off. Get 81 on the left. And x plus 4 squared on the right. Now we can take the square root of both sides. If we take the square root of both sides, we get 9 equals x plus 4, because these cancel off, and then just subtract 4. When you take the square root on these, just take the principal square root. The logarithm problems can only have positive solutions. So x equals 5 is the only solution. And again, you could check that in the original if you wish to, but it all looks okay to me. But just try to remember, when you're solving log equations, the negative solutions generally don't check out. We can't put a negative 5 right there. It's not part of the domain of this logarithmic function.